Hello everyone, welcome to this session. Our topic is extractions of metals, and we are discussing about the extraction of the moderately reactive metals. So far, we said that the extraction of the metals is mainly dependent on the reactivity series of the respective metals. So here, we are trying to discuss the extraction of the moderately reactive metals. So moderately reactive metals are the metals that are found at the middle of the reactivity series. That's why they are called the moderately reactive metals. This means that they can moderately react with the other components or other substances. So far in our past video, we discussed that there are four main stages for the extraction of the moderately reactive metals. There is mining and the concentration of the ore, roasting in air, reduction of oxides to metals, and then purifying the metal. In the previous video, we discussed the two of them, mining and the concentration of the ore and the roasting in the air. So today we'll finish up with the remaining two stages for the extraction of these moderately reactive metals, which are reduction of the oxides to metals and the purifying the metal. So let's start with the reduction of oxides to metals. Here, the roasted ore that was roasted in the second stage must now be reduced to respective metals, and the reduction it occurs at a very high temperatures. And the materials that are employed for the reduction process are mainly the carbon or the carbon monoxide. So let's take an example when you're trying to extract the iron from the ore, such as maybe iron trioxide, plus the carbon monoxide gas you later on result to the iron plus the carbon dioxide gas. So there you have it, the uh, the roasted ore of the iron trioxide is reduced by the employed carbon monoxide, uh, resulting to the iron as the respective metal, and plus the carbon dioxide gas. The same goes to the zinc oxide plus carbon result to the zinc plus carbon monoxide gas. So from there you get the respective metals. So that's how reduction of oxides to metals takes place. Moving on, let's see the purification. It can also be known as the refining. Now we have to know that very often the product of the reduction process is never pure. So it means that there can be some impurities that are within uh, the obtained product. Now, the product has to be purified first before being put into use. Now, purification is normally done through a number of ways, which include as follows. The first way that can be used to purify the, the given product include the electrolysis. The electrolysis is used to produce a pure metal directly from its molten compounds. Take an example, examples of metals which are purified by the electrolysis are the copper and zinc. While the copper produced in large scale is purified by the electrolysis, a process called the copper refining. So a copper refining is there as the main process to purify the copper. So it is there to provide the copper that is produced after the reduction process. So the copper refining is done within the large scale for the obtaining of the copper. The other way of the purification is the oxidation. The molten crude metal is exposed to hot air in a furnace, whereby the impurities in the crude metal are oxidized with oxygen from the air. They escape as vapor or form as scum over the molten metal, which is then removed by skimming. So, however, this method is used only when the impurities have a greater affinity for oxygen than the metal. So, this is the way of obtaining the pure metal by exposing the metal or the crude metal to the hot air within the furnace, whereby the impurities are there, which are there, are just oxidized, are just burnt as the impurities are just burnt for a time So this method is only used only the impurities that have a greater affinity for oxygen than the metal. The method is applied in the manufacture of the steel from pig iron and in the purification of the tin and lead. So those are the main places of the purification which can be done by using the oxidation. The manufacture of steel from the pig iron and the purification of tin and lead. The other purification way is the distillation. In distillation, the crude metal is heated in a furnace until the pure metal evaporates, leaving behind the impurities. So the pure metal is being obtained by heating a crude metal within this furnace, whereby the pure metal is evaporated, leaving the impurities behind. The vapor is then collected and condensed in a separate chamber, whereby you obtain a pure substance. Now, this method forms an internal part in the extraction of the zinc, cadmium, and mercury. A further distillation, usually in vacuum, gives a very pure product. The other purification ways include the formation of the carbonides. Very pure nickel and iron are made by forming their volatile carbonides, which are then decomposed by heating. So this is there as the other way of the purification. The other one is zone refining, whereby this recently developed method is used to produce the silicon, the germanium of the extreme purity. In this method, simply a small high-frequency induction furnace is placed around one end of a long rod of the metal, and a thin cross-section of the metal is melted. Then the furnace is then moved slowly along the rod. Pure crystals of metal separate from the melting metal, but impurities remain in the liquid and are carried along to the other end. So there you have it. I hope it's clear, guys. Thank you for listening. So we finished covering the main stages for the extraction of the moderately reactive metals. Thank you.